When I talk about arrhythmia, what does it mean?
No, please, it's an irregular heartbeat or heart rate.
I was asking about arrhythmia. What is that arrhythmia? Can you hear me? Can you hear me?
Yes,
Yes, please.
Why are you not answering my question? Arrhythmia.
So can you say it's when the heart beats faster than normal?
No, I'm asking you a question and you say, can you say? Are you asking me a question? Gloria.
Yes, dog. No, please. So it's when the heart beats faster than normal or irregular beat.
You see, can you say? What does it mean?
Dog, sorry.
Simple way. I can decide not to ask you a question and just be teaching. But I want to ask, you answer it. Then we try to correct you because you have orals in there. If it's not orals, I will not be asking question. So what is arrhythmia?
Dog, irregular beats of the heart.
So irregular beat of the heart. What does it mean to say irregular beat of the heart?
It's when the heart beats faster than normal.
So when it beats faster than normal, that is arrhythmia. That is irregular beat. When it beats slower than normal, what does it mean?
Bradycardia.
So what does it mean? When you said when it beat faster than the normal, then it's irregular beats. That is arrhythmia. When it beats slower than the normal,
Bradycardia.
therefore, what is arrhythmia? What is arrhythmia? Simple question. What is arrhythmia?
Doc, please, can we say, hey, Doc, please, abnormal cardiac rhythm.
Can we say, hey, I didn't know. So when you talk about arrhythmia is simply means abnormal rhythm. Abnormal rhythm. So we talk about abnormal rhythm. The reason why we're using the word abnormal rhythm, you were talking about irregular, but you were thinking about only the first. Abnormal rhythm Can you see the screen?
No, please.
Can you now see the screen?
No.
So you can see the screen. Okay, so when you talk about rhythm, I was trying to use the screen, but
Please, we can see now.
can see.
It just went off.
So you cannot see again. Hmm? You cannot see again.
No, we can't see.
Okay, so let me move on. So you can see.
We can see now.
So some are having eyes, some are not having it. Oh, God. Okay, so let's go on. I'm trying to see whether I can still use it. So so arrhythmia, when you talk about arrhythmia, simply what we mean is abnormal rhythm. You're talking about irregular, and also say irregular heartbeat or irregular rhythm. That is abnormal, irregular rhythm. And don't think that when you have tachycardia, that is arrhythmia. Tachycardia is irregular rhythm or abnormal rhythm. Bradycardia is irregular or abnormal what? Rhythm. So if we have tachycardia, it's still abnormal. If we have bradycardia, it's still what? Abnormal. And therefore, if a patient comes with bradycardia or tachycardia, we term it as abnormal rhythm or irregular rhythm or even irregular heart rate. Is it clear? Is it clear?
Yes, please. Yes, please.
So when a patient comes with irregular heart rate and is slow, we say it's bradycardia. When it's fast, we say it's tachycardia. Therefore, this slow or fast or bradycardia or tachycardia, we term it as what? As irregular. And this is simply means arrhythmia. So arrhythmia is that. Because we are talking about arrhythmia, it means arrhythmia means abnormal. It means we have a normal rhythm. And to the normal rhythm of the heart, we term it as sinus rhythm. Sinus rhythm. So when you say sinus rhythm, then we are talking about the normal rhythm. Sinus rhythm. We're talking about the normal rhythm. And when we are talking about arrhythmia, we are talking about abnormal rhythm. So sinus rhythm will give you heart rate between 60 to 100 beats per minute. That is a sinus rhythm. Normal heart rate is between 60 to what? To 100. So if a patient falls below 60, then we say it's low or bradycardia. When it's above 100, then we talk about tachycardia or we talk about what? Fast. So you can say fast or tachycardia, slow or bradycardia. Is it clear? So
No, she secure chat me.
Oh, okay.
Yeah, she just sent it.
Insia,
Let me talk to her. And let's see, what's her name?
Hold on.
Caitlin.
Caitlin. Her number is 4482.
4482.
Insia. So you'll be doing your own thing. This is what I hate about Zoom. You're doing your own thing outside and your lecturer will be serious talking. Serious talking and you'll be doing your own thing outside. You come back and say, I don't understand. Okay, so we are talking about sinus rhythm, the normal rhythm of the heart. And for you to attain this normal rhythm of the heart, there should be a conduction. So when we are talking about arrhythmia talks about conduction of electrical impulses. Some of you are recording me. You record and give it to your friends. Don't think it's not quite. Some of you are recording. You're giving it up because you don't pay attention. But you record. So when you talk about arrhythmia deals with electrical impulses. These electrical impulses will start from synovial node to the Purkinje's fibers. And this transmission is termed as chronotropic. So when you talk about chronotropic effect, it's talking about the electrical impulse transmission within the myocardium. When you talk about inotropic, it's talking about contraction of the myocardium. And the contraction of the myocardium could be positive or negative. So you could have negative inotropic effect. You could have positive inotropic effect. When you have negative inotropic effect, then you'll be thinking about the contractility is slowing down. When you talk about positive inotropic effect, you are increasing the contractility. You can also talk about chronotropic effect. Well, chronotropic effect talked about conduction of electrical impulses. So the conduction could be negative and could be positive. So you could have negative chronotropic effect. You also be having positive chronotropic effect. So negative chronotropic effects, we'll be talking about slowing down the conduction. And slowing down the conduction is bradycardia. You have positive chronotropic effect. And that will also, that's a fast conduction. That's called tachycardia. It is called tachycardia.
Hello, Doc.
Mm.
Please, the statements you made concerning the Purkinje fibers after the conduction of electrical impulses, please, can you repeat it again?
Said a lot of things. So what is the statement you made? About which statement? When I'm teaching you, I don't look, I teach without looking through anything. So if you allow me to go, then you come back and say the statement that you think I'm a computer.
No, please.
I teach without going through anything. That's what I do. In class, I will come and be teaching. I like teaching more than lecturing, more than presenting, like preparing a notes and prepare notes and a comment. I like teaching for you to understand. So if you don't prompt me and I move on and you come back to tell me that the statement, which statement? Can you record the statement I made?
That's why I wanted you to repeat it because I can't remember. I know it had to do with you mentioned Purkinje fibers. That's all I heard.
I'll come back to that.
Yes, please. Thank you.
Come back to that. So these are all introductory, and you need to understand the introductory portion. Arrhythmia is difficult, but because we are not taught as pharmacists, and this is the pain I have in me. The pain I have in me is that when you are the ward, they will teach the medics. Pharmacists, we are not taught like that. So the medics will understand to the extent that they will understand our area more than pharmacists. And we are not serious. We are not serious. Because after what? I'm going to dispense. After what? It's the money that I want. This is our character. We need to be taught. That is why I like teaching. I want to teach for my students to understand. It's not for the exams alone. I want to teach so that in future you can hold on. So I am teaching. Stop doing other things. There was a lady in Sia was talking about a number. He was giving number to somebody else. Then you'll be doing other things. Then you come back and say, Abena, come back and tell me. And you repeat. Once I've moved on. Coming back to.
No, please, I'm sorry.
Go away. Okay, so this is, I'm saying that arrhythmia deals with, I'll come back to what you are asking, I'll come back, but I want you to understand. I'm talking about arrhythmia, and I'm saying arrhythmia deals with conduction of electrical impulses. In conduction of electrical impulses, we refer to it as chronotropic. We could also have dromotropic effect. So we have inotropic effect. We have dromotropic effect, and we have chronotropic effect. Arrhythmia deals with chronotropic effect. Heart failure deals with inotropic effect. Talking about the contraction. So when you have the slowdown of conduction of electrical impulses, then it's giving you negative chronotropic effects. When you have fast, then it's giving you positive chronotropic effect. So when you have negative chronotropic effects, then you'll be thinking about slowing down conduction. This will give you bradycardia. When you talk about fast, then you'll be talking about fast conduction, you're talking about tachycardia, fast conduction, tachycardia. And this is positive chronotropic effect. Positive chronotropic effect. So fast and slow will give you arrhythmia. And I was saying that we have what we call sinus rhythm. That is the normal rhythm of the heart, normal heart rate of the heart. We call it sinus rhythm. And I say that for sinus rhythm to occur, there's a conduction. There's a conduction of electrical impulses. And the conduction of electrical impulses go through certain pathway within the heart. And these are the pathway. It starts from, that's what I wanted to use. I wanted to use the board.
Hello, Dr. Tataka.
Talk.
Doc, please. I'm a bit confused. I thought chronotropic has to do with heart rate, then dromotropic has to do with conduction of electrical impulses.
What? Come again.
Please, you were saying that chronotropic has to do with conduction of electrical impulses, but I thought that one was for dromotropic effect.
Dromotropic effects talking about the speed of conduction.
Yes, please. Thank you.
Chrono is talking about conduction. I don't know why I want to use the. So let me go on. I wanted to draw the heart and show you. You can see the board.
Yes, please.
Yes, please.
I'm finding it difficult to get the pen. So let me ask you, do this for me. You just draw a circle to represent the heart. And can you locate the sinoatrial node and divide the circle into 4? Can you locate the sinoatrial node for me?
Yes, please.
So put a knot there on top of the right atrium. And put the knot down. As the AV node. Do you know where the AV node is located?
No, please.
Hold on for me. Hello. Hello.
Hello.
It's raining here. It's this tender, I'm afraid. That's the internet. Okay, so draw the AV. You know the AV node. Can you locate the AV node? It's in the same chamber down. The AV node. AV node. Do you know where you can locate the AV node? Yes or no?
Yes, please.
No, please.
I'm trying. I've called somebody to come and help me. Such that I was having it. It went. I just want to draw and locate it. That will make it easier for you to appreciate. Oh. Yeah. Uh, so where did you get to? It went. I don't understand why. Why is it that I wasn't getting it? Yes, I'm using it to scroll. I didn't see this. Annie was coming. It's PA. Soon. Go here. Hello, class.
Hello.
Yes, please.
Can you see the board?
Yes,
sir.
please.
Yes,
Please.
Can see. Okay. So assuming this is the heart, Assuming this is the heart, these are the chambers that we have 2 chambers down. We have learned about heart failure, so you know this. On top here, we have sinoatrial node. We have sinoatrial node. Over here, we have AV node. Over here, we have AV node. AV node. So AV node and sinoatrial node. And we have this as the bundle of this. We have Purkinje's fibers. The bundle of this is branched into Purkinje's fibers. So the Purkinje's fibers, we have is branching to left, branching to right. So this is the right, branching to right ventricles, branching to right, left ventricle. This is left ventricles. So this is the pathway I was talking about. This pathway where we have impulses. The sinoatrial node serves as a pacemaker. And these pacemaker will release impulses. They set the pace. They would initiate the transmission. And therefore they term it as a pacemaker because they will initiate the impulse release. So sinoatrial node will release impulses. And these impulses will travel through these areas. Some will travel through here, some will travel through here, and they will converge at the AV node. They will converge at AV node. And then AV node will take all these impulses. These impulses will go through the bundle of this. The bundle of this is a bridge that is connecting the chambers, 2 chambers up and 2 chambers down. So this is the bundle of this. So impulses transmission will be collected from the sinoatrial node, will be collected by the AV node. These impulses will go through the bundle of this. And these impulses, after going through the bundle of this, they will branch into the right and the left ventricles. And these are Purkinje's fibers. Purkinje's fibers. So when you have impulses transmission from sinoatrial node to the AV node via the bundle of this to the left and right fibers, Purkinje's fibers, without any interruptions, without any obstruction, then we term this as a sinus, to give a sinus rhythm. At times there could be obstruction here at the AV node. At times there could be a block here. So we have the left branch block. We have the right branch block. At times there will be a block here at the AV node. So when you don't have any interruption and there's a smooth flow of impulses from the sinoatrial node to the AV node via the Purkinje's, via the bundle of this to the Purkinje's fiber. These fibers extend to the remotest part, anterior part of the ventricles, such that impulses can get to all these areas and go and cause stimulation. Go and cause stimulation of the cells over there. So when you have uninterrupted flow of impulses from the sinoatrial node to the AV node, via the packages, via the bundle of beats to the packages fiber. When you have such a thing, we term it as what? Term it as the sinus rhythm. This will give you a sinus rhythm. Is it clear?
Yes, sir.
Is it clear to everybody?
Yeah.
Yes, sir.
Good. So I want you to understand arrhythmia is difficult. It's difficult. Arrhythmia is difficult to understand. So stop your extra things doing and listen. Arrhythmia is difficult. So we talked about the heart. You now understand. You now understand the sinus rhythm. You understand the sinus rhythm. So this is the AV node, the sinatral node. This is the AV node. And these are, if I say myocytes, what are the myocytes? If I say myocytes, what are the myocytes? What are the myocytes? I didn't know.
Myocytes are cardiac cells.
Myocytes are what?
Cardiac cells.
Myocytes are cardiac cells. Myocytes are cardiac cells. So I want you to understand something. We have learned about, what I have said is that arrhythmia is abnormal rhythm or irregular rhythm or irregular heartbeats. In the irregular heartbeat, you could have slow, you could have fast. All these, one is slow or one is fast. It's irregular. And because it's irregular or abnormal, we term it as arrhythmia. And I say that arrhythmia deals with conduction, chronotropic, conduction of impulses, electrical impulses via a certain pathway within the heart. And this conduction of impulses will cause the contraction. So we have the sinatral node here. Impulses will be traveling through. It will release impulses. And these impulses would be traveling through all these areas. And it will converge at AV node. And AV node will now release the impulses to the packages fibers via the bundle of base. When you have one interrupted transmission, then the rhythm that we are going to get is the normal rhythm. The normal rhythm is termed as the sinus rhythm. This is what I've got into. And I want to explain, there are certain terms that you'll be meeting. And there are certain terms that will be meeting. But let me say this before I get to the terms. Let me explain this. The cells of the heart, God has made it. It's so specialized. You have a specialized cell. It's so unique in the sense that if there's a problem here, if there's a problem at the pacemaker sinatral node, if sinatral node